Section 6.8 is applying coordinate geometry. So we're going to continue to work with our coordinate plane, but this time we're going to look at using variables for our coordinate values. Rather than a specific position on the graph, 1, 3, 2, 7 for the vertices, we're going to be looking at vertices that have variables for their coordinate values. So using variables for the coordinate values allows you to show relationships that are true for a general case rather than a specific triangle or parallelogram or whatever. So how could you place a general triangle with its midsegment on the coordinate plane? Well, there's a couple ways to do this. One would be to just stick a triangle somewhere up here and put its midsegment on. If we did that, we'd have to label this point something like AB. This point we'd have to label something like CD. And this point would be EF. Okay? Another way to do this would be to set it on the origin. This way, when I come over to here, I can just call this point 0, 0. I can call this point AB. And this point would be C, 0. And then the midsegments here. The last way I could do this would be to set it across the origin. And I'm going to wait to label these for just a second. So let's say if we're going to find the midpoints here. Well, the midpoint here would be A plus C divided by 2, and B plus D divided by 2. And this midpoint would be E plus C over 2, and D plus F over 2. This one's a little easier to find the midpoints, you can see, because 0 plus A is A over 2, and then we just have B over 2. The midpoint here would be A plus C over 2, and then B over 2. So a little bit easier to work with midpoints when we place one of the things on the origin. But let's be a little creative here. What if I made this point negative 2A, comma 0, and if I made this point 2B, comma 0, and then I could make this point 0, comma 2C. Now when I go to find the midpoint x plus x divided by 2, I just get negative a. Y plus y divided by 2, I just get c. Over here, 0 plus 2b divided by 2 is b, and my y coordinate is c. So I think you can see that by playing around with where I place this on the coordinate plane and what variable terms I can use, I can make this a very difficult problem or a very easy problem. So let's do a couple problems. We're going to state that SQRE is a square and SQ equals 2A. And I want to put this, I want to put this around the origin. So I'm going to just kind of make a little square. It's 2 units in each direction from the origin. I'm going to call this point, well, let's see. We've got SQRE. We know that SQ's distance is 2A. So if I make this vertice A, comma 0, and this one negative 2A, comma 0, negative A, comma 0, then the length of this is from negative A to A, which is 2A, and it's obviously, back up. I'm sorry, we can't call that 0. But we know that the x coordinates are going to be A and negative A because SQ has a distance of 2A. Well, if it's a square, then this also has to be 2A, which means that up 2 units there, or up 1 unit would be A, and down 1 unit would be A. So filling in the rest of the ordinate pairs, and negative A, and A. So again, by placing this on the origin, things become quite simple to get our variables and figure out what is what. I know this doesn't make a whole lot of sense right now, but we are going to get there, trust me. Okay, let's do another one. Suppose TRI is an isosceles triangle where TI equals 2A, TI equals 2A, and the y-axis is the median. And again, we want to find out what the values are for each vertice. So if TI, and I'm going to make that my base, is 2A, then if I call this A and this negative A, there's my base of 2A. And then it really doesn't matter how high my value is. I'm going to call that B. So my vertices are A, 0, negative A, 0, and B, 0. Oops, 0, B. Oh, my eraser's not working. Okay, so 0, B. So again, placing it on the origin makes things pretty easy. This is really all we're going to do on the video. We're going to look at another example together in class to give you a little better idea of where we're headed with this. But remember again, the idea is that we're using general terms, not specific numbers, to do polygons on a coordinate plane.